Hello, everyone, and welcome to section 2.7 in Precalculus, solving nonlinear inequalities, which is an application of zeros. So you already know how to solve equations with x squared in them. Remember, when you see an x squared, I'm going to say this all year, when you see an x squared, set the equation equal to 0 and factor. That hasn't changed. We are still going to do that. So I see an x squared. By the way, some of you are a little lazy about writing the zeros equal to. Make sure you write the whole thing. X minus 3 times x plus 1. And so either x minus 3 is equal to 0 or x plus 1 is equal to 0. So either x is equal to 3 or x is equal to negative 1. And think about why that's true. Because if x is negative 1, then you'll have negative 4 here, which isn't helpful, but you'll have 0 here, and that'll make 0. If x is 3, you'll have 0 is equal to 0 times 4, which, again, the 4 isn't important, but the 0 is. And that's why we set things equal to 0 and factor, because when two things are being multiplied to make 0, one of them has to be 0. Now, these questions are just a little bit harder, but they start the same way. I just want you to know this is the most missed section on the test. I don't know why. Every year I tell everybody this, and it's still the most missed. Okay, so you're going to start it the same way. You're going to say x minus 3 times x plus 1, and you can leave it greater than 0, but I would solve it just equal to 0 and get your two numbers. Okay, so step 1 is to start the same. But here's the new step. Those two numbers tell you when something is equal to 0. Well, something can only be one of three things. It's either greater than 0, less than 0, or equal to 0. So we're going to just make a number line. Step 2, make a number line. Put on there the 2 points that you want. Add the points. Your book is going to call these critical numbers. So add your critical numbers and then test intervals. So it's an inequality. And just like any inequality, it's going to have an answer like x is greater than. So we just have to figure out where the answer is. So, and test the intervals in the factoring. So I'm going to try the number 4. When I put in a 4, I get 4 minus 3 times 4 plus 1, which is 1 times 5, which is 5, which is positive. So what's great is that if this is positive, then this entire interval is positive. Okay, so I'm going to put positives, a whole bunch of them, so that you can see this entire, by checking that one point, I know this entire interval is positive. Any number I check in there is going to be positive. Now I'm going to check a number here. I'm going to check 0, because it's between negative 1 and 3, and it's easy. So 0 minus 3, 0 plus 1 is negative 3 times 1, which is negative 3, which is negative. So this whole interval is negative. Now, if you're thinking to yourself, I bet the other interval is positive. That does work in Algebra 2, where the problems are always easier. In pre-calc, we are definitely going to have some where it goes positive, positive, negative, or there's going to be different situations. So check a number smaller than negative 1. I'm going to check negative 2. I always pick the smallest number I can. So I plug in a negative 2, negative 2 minus 3, and negative 2 plus 1. Now, I had to tell you, I actually don't figure out the number. I just sit there and say, well, that's going to be negative, that's going to be negative, and that's therefore going to be positive. I don't usually bother to actually calculate the precise number. So the question is, where is this function, which we rewrote like this, where is this function greater than 0? It's greater than 0 from negative infinity all all the way up until -1, and then I'm going to put a parenthesis because it doesn't say equal to 0, it's greater than 0. And so the official symbol is union. That combines two answers. And from 3 to infinity. And this is why I love interval notation. Oops, I just realized I put a bracket there. That's wrong. Parenthesis. Because it just looks like the number line from -infinity to -1, union from 3 to infinity, where I would have to really think about answers that look like this. X is less than -1 and X is greater than 3. And then people end up trying to put them together as one thing and they get it wrong. They go like this, like, oh, I'll put them together. But that doesn't make any sense because if you took away the X, is 3 less than -1? No. So use interval notation. Okay. All right, so I'm going to do a bunch of problems. This is it. That was the whole lesson. I'm going to do a bunch of problems this way, but there is, in my opinion, a much faster and easier way to do these. But for some reason, only some people understand it. It's like a different kind of concept. But for people that get it, they love it. So for me, I would just consider the graph of x squared minus 2x minus 3 because I love graphing. So y is x minus 3. It still starts the same way. And then I plot it, which is 3, -1. And I am not even going to be any more specific than that. I know it's an upward parabola. So it looks like this. So the question is, where is y greater than 0? Find a point where the y is greater than 0. So the y is greater than 0 for all these ordered pairs. For any one of these ordered pairs, this one, -2, 1. For this one up here, somewhere around, well, I mean, they're not exact points, but -2.54. This one over here, what does that look like? Oh, I'm really far off, aren't I? But if it was 3, 2, but you see how on every one of these points over here, the y coordinate is positive. This point down here, y coordinate is negative. This point right here, y coordinate is negative. So using the same thing that we did with the highlighter before, where we talked about different sections, for this section of the graph and for this section of the graph, the y coordinate is positive. And how can we identify that section? From -infinity to -1, and then from 3 to infinity. So for me, instead of testing points, I would just make a super quick sketch in my head or on the paper. So I'm actually going to be doing it both ways for every problem, just so that you can see and hopefully find a way that works for you. It's possible that my doing it 2 different ways is the reason why it's the most missed section on the test. So if you want to, you can stick with one way and keep skipping over the graph. But I do know that kids who like the graph love it. So I'm determined to keep teaching it. All right, in case you missed the steps before, write the inequality in general form. That is, set it equal to 0. And then factor. Identify the zeros. Your book is going to call these critical numbers. Make a number line. I wrote using the zeros, marking the zeros, meaning the critical numbers. And then plug numbers into the factors in the different intervals. It's kind of obvious, but I'll write it down anyway. And then write your answer in interval notation. If there's more than one interval, make sure you use the U to combine them. All right, let's do these. So this one's already equal to 0. So I factor -3 plus 2. I'm just going to change it to equal to 0. I found out that the zeros are 3 and -2. I make a number line. Here's my -2. Here's my 3. And then I test points. So if I test 4, when I put a 4 in here, so you're testing it in the equation, and put it in the factored one, not in the original. That's too hard. Because if you put it in here, I can say, well, 4 minus 3 is positive, and 4 plus 2 is positive. And a positive times a positive makes a positive. And then in this interval, I'm going to test 0. I always test 0 whenever I can. And 0 gives me 0 minus 3, which is a negative, 0 plus 2, which is a positive, and a negative times a positive gives you a negative. In this interval, I'm going to test -3. You can test -4, -5, but it has to be smaller than -2. And -3 minus 3, don't overthink it, just say negative. You'll go a little faster. And then -3 plus 2 is also negative. So I get a positive. So my question is, where, for what values of x is this equation less than 0 on the interval -2 to 3? This is not an ordered pair. Not an ordered pair. This is the one that I do not like because it looks like an ordered pair. It's an interval. It's easier when it has a bracket, but because this is just less than, it's not a bracket. Okay, if you want to skip to the next problem, you can, but I'm going to quick do the graph. So if this were me, when I got to the 3 and -2, I would just say, oh, 3, -2, it's an upward parabola. Where is this parabola? Remember, this is the y. Y is x squared minus x minus 6. That's what I've just graphed. Y is x squared minus x minus 6. So where is y less than 0? For all these points here. And what interval is that? I think this is the hard part. This is the interval. So that's why the answer is the interval -2 to 3. So easier than testing points. Okay, number 2. First step, set it equal to 0. Second step, factor. Always try and factor out first, but I don't see a number that goes into all of them. So it must be this kind of factoring. So I know it's going to be x squared and x. So I kind of look ahead to the x squared, which is going to clearly be my outers, and the 32x, which is going to be my inners. And there's actually only one way to make 3x squared. It's not by giving this one the 2 and this one the 1. It's going to have to be 3x squared, and this is going to have to be negative. So if this gets the 1, to make my 2x cubed, this is going to need the 2. And if this has the 2, this is like a little puzzle. If this has the 2, and I need to get to 32, this must have a -16. And sure enough, -16 times -3 makes +48. So factoring with 4 is like a little puzzle, but I think it's easier to put the puzzle together than to do the guess and check when there's only 3 terms. I'm not done. You do need to factor these completely. I hope you're already better at factoring than you were at the beginning of the year. You've used it a lot now and seen its value. Keep working on it, though. It's important. And so I make my number line. I put on it -4, 4, and there's no shame in doing this out real quick. 2x is equal to 3. Kids that try and do it in their head, sometimes they get it wrong. -4. Notice I am not doing a fantastic number line. Oops. I'm not making all the tick marks. I'm just putting on the zeros. I do have to put them in order, though. So the 3/2 has to come before the 4. So now I'm going to test a point. So I'm going to test in x plus 4 times x minus 4 and 2x minus 3. So the first number I'm going to test is a 5. A 5 would make this positive. A 5 would make this one positive. And a 5 would be 10 minus something is still going to be positive. Now I'm going to test something in this interval. So this is 1.5. I just need a number between 1.5 and 4. So I'm going to say 3. 3 plus 4 is positive, but 3 minus 4 is negative. And sometimes you might have to do a little math. So 3 times 2 is 6. That's going to come out positive too. Positive times a negative times a positive is a negative. So now I'm going to test something in this interval. I'm going to choose 0. Whenever it goes from negative to positive, I always pick the 0. 0 would make 0 plus 4 is positive. 0 minus 4 is negative. And 0 times 2 is 0 minus 3 is negative. So this ends up being positive. I know some of you are going, I'm just going to do one interval and then it'll go positive, negative, positive, negative. Well, for the first few examples, yeah, but it's going to get harder. And then the last section. Have I run out of colors? I guess we'll do blue. So I'm going to choose negative 5. Negative 5 plus 4 is negative. Negative 5 minus 4 is negative. See how I'm not actually doing the math? It's so much easier. And negative 5 times negative 2 is negative 10 minus 3 is still negative. So these two negatives make a positive, but overall it's going to be negative. So what are my answers? So my final answer is going to be, let's see, we want it to be greater than 0. So where is it greater than 0? In those two intervals. How do I express that in interval notation? If I asked you to make the graph, then you could actually, it's open circle, this would be the graph. But if they just ask for interval notation, then the answer would be parenthesis, -4 to 3 halves, union 4 to infinity. That's the final answer. You may skip to the next problem. Or my graphing people, do you want to do that so much faster? So for the graphing people, you think to yourself, here's -4, here's 3 halves, here's 4. It's a cubic function that's going up. So I'm going to go up. That ends up. So ends up, which means it starts down. So I'm going to go up. I'm going to come back down through there and then go up again. And I want to know where it's greater than 0, right? When we first solved it, greater than 0. So what intervals always go on the x-axis? Well, for this whole interval, the function is down here. Where's the y greater than 0? From there to there and from there to there. So just by knowing the general shape, I'm literally able to jump to the answer right away. Next one. So I start to do it and I realize that I can't factor it. You can do x plus 2 times x plus 2, but that will give you 4x in the middle, which isn't good. You could try x plus 1 times x plus 4, but that's going to give you 5x in the middle. So do we have any other way of solving an equation that's equal to 0 besides factoring? Yes, we do. Quadratic formula. See, I know you're excited now. All right, so quadratic formula. If you can't factor, use the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a gives me -2 plus or minus. This is going to be 4 minus 16, which is -12. Am I putting the square root of -12 on my graph, on my number line? I am not. So unfortunately, now you are going to have to think a little harder. If this graph has no real zeros, now you think about this. It has no real zeros. It is an up parabola, right? And it has a y-intercept of 0, 4. Can you draw an upward parabola that has a y-intercept of 0, 4 and doesn't have any x-intercepts? No real zero means no x-intercepts. So you're going to have to draw it like this or like this. But let's not get too complicated. I'll just leave one of them there. So when is this parabola greater than 0? Where's the y? Like if this is y is equal to x squared plus 2x plus 4, every single one of these points has a y value that's greater than 0. Every single one of these. The y value is never negative. So the answer is all real numbers. And that's why I keep teaching the graph also, because in the end, it just makes the most sense. Now, if you're thinking, but I didn't want to do it the graph way, I was doing it the other way. All right, if you're doing it the other way, as soon as you see that there's no answers, then either it's going to be all real numbers, or what do you think is the other possibility? No solution. If this had been a downward parabola that was below the x-axis, it would have had no solution. So how can you figure that out? You can just test a point. So you can still test a point. It's just that now the answer is going to be for the whole number line. So just pick, well, I was going to say 0. Yeah, you can still pick 0. So at 0, you get 4, which is positive. So since 0 is positive, the whole interval is positive. And so the answer is all real numbers. So this is where I really think the graph is easier to understand. But you can still just test a point, but now there's no zeros. You just test any point. All right. So this is, see, so the difference a lot of times between Algebra 2 and Precalc is you learned this, or at least you were supposed to learn this in Algebra 2, but you just wouldn't have gotten all these tricky ones that we're about to do. Ooh, another tricky one. Okay. So there's a little bit of a change here with the critical numbers. So you still want to do 2x minus 7 over x minus 5 minus 3 is less than or equal to 0. But I personally think that this is too hard to work with. So I don't know if you remember when we were graphing them, I said I would get a common denominator. So I would make them both over x minus 5. So now I get 2x minus 7 minus 3x plus, watch that plus there, you're distributing the negative 3, plus 15 all over x minus 5, which gives me, not 5x, which gives me negative x plus 8 over x minus 5. Now, normally you would clear the fractions. You can still clear the fractions. So multiply both sides by x minus 5, x minus 5, and you get negative x plus 8 is less than or equal to 0. So this is a very easy problem to solve. I actually usually just change it to equals 0. You don't need to keep the less than there. So I put the x on the other side, and I get x is equal to 8. Okay, so if there is a denominator, then that adds a critical number. So when you go to make your number line, yes, 8 is going to go on it, but so is 5. because it's critical. X can't be 5. So that ends up going on the chart as well. Okay, let's test some points. So we're going to test them in negative x plus 8 over x minus 5. I'm going to test 10. So when I test 10, I get negative 10 plus 8 over 10 minus 5, which is a negative, over a positive, which is a negative. I'm going to test a number between 5 and 8. I pick 6. So negative 6 plus 8 is positive, over 6 minus 5 is positive. So positive. I think the last one's negative. Let's find out. So I pick 0, which is less than 5. And 0 plus 8 is positive. And 0 minus 5 is negative. So this question was, where is this whole thing less than 0? Where is it negative? The final answer would be from negative infinity to 5, but I get to use brackets this time because it's or equal to union 8 to infinity. Okay, there's one little catch to this problem. This is pretty hard to catch. If you miss this, I'm going to take off very minimal credit for this because this is already, in my opinion, the hardest problem in this section. But in addition to that, x can't be 5. That's the domain. X can't be 5. So you actually have to change this to a parenthesis. If you do this entire problem and get this whole thing right, and you accidentally put a bracket there, just don't know that I'm gonna really worry about it. But I need you to know that it's not a bracket. It is a parenthesis. Okay, people that want to see it graphically. How would I do it graphically? I would go to this step, which is where we kind of used that last time. And I would say, oh, it has an asymptote at 5. 1, 2, 3, 4, 5. It has a horizontal asymptote of -1. And it has an x-intercept, where's the top equal to 0 at 8. So 5, 6, 7, 8. And its y-intercept, putting in zeros in there, is -1 3/5. So down here somewhere. So I know it goes like this. And then I know it goes like this. So now, can I see it? Yeah, really easily without testing all those points. It's definitely negative through this interval, right? It's below the x-axis. And then for this interval. So from negative infinity to 5, but this will also help you see that it doesn't actually touch 5 because there's an asymptote there. And then it's positive, but then from -8 on, it's negative. So again, just a really great thing to do. Now, let's say you kind of understand the graphing method, but you don't actually want to make the graph. This will be in the graphing calculator allowed section of your test. So when you get to this step, -x plus 8 over x minus 5, you could just graph it on your graphing calculator and see where it's less than or equal to 0. So keep that in mind as an option. Okay, we have 4 more. We can do it. If you would like to try these on your own, you can. Okay, so it's already equal to 0. Second step is to factor x plus 1 times x plus 1. So the only number on my chart is going to be -1. There's only one number. So there's only 2 intervals. All the other ones had 3 or 4 intervals. So I am going to test 0. So when I put a 0 in, I get 0 plus 1 times 0 plus 1, which is positive, positive, positive. So this whole, I only checked one number in the interval, but the entire interval is positive. I'm going to test something smaller than -1. I'm going to test -2. -2 plus 1 is negative, and -2 plus 1 is negative, and a negative times a negative is a positive. So what does that mean? It means that where is it? I'm trying to find where it's less than 0. Where is it less than 0? It is never less than 0. Okay, this is another tricky one though, because the question actually says, where is it less than or equal to 0? Well, remember, this marks the spot where it's equal to 0. So the only answer is at x is equal to -1. That is the only answer. So it's never less than 0, but it is equal to 0 at x is equal to -1. How could you have done this faster graphically, my graphing people? So this is a parabola that goes up, crosses at 1, and bounces at -1. It looks like this. So where is this parabola less than 0? Again, it's not underneath the axis, but it is equal to 0 right at that spot. So the answer is -1. It'll be always interesting to see who chooses the graphing method and who chooses the other one. I like them both. I really just want you to get the right answer. So the method you choose doesn't matter to me. Okay, it's already equal to 0. So I try and factor. 5 and 1 are my only choices, which would make 6 if they were both positive or negative, which would make 4 if one was positive and one was negative. So I can't factor. What does that mean I have to do? Again, more fun. You can't really have any more fun than this, right? So fun. Quadratic formula. So -b plus or minus the square root of b squared minus 4ac all over 2a. So -3 plus or minus 9 minus 20 is, a negative number again. So this has no real zeros, which means it has no x-intercepts. So the answer is either going to be, either all real numbers or no solution. Okay? So just pick any point. I pick 6. If I plug a 6 in, then I get 6 squared plus 3 times 6 plus 5. I'm not even going to calculate that. Is that going to come out to be less than 0? It is not. Okay, this is definitely going to come out to be positive the whole way. So if one of the numbers is positive, the whole entire thing is positive. So when is it less than 0? The answer is no solution. It is never going to be less than 0. It's never going to be equal to 0. Next one's already equal to 0, so I jump straight to the factoring step. I'm going to do 2 and 2. So my only critical number is 2, which means I only have 2 sections to check. I'm going to check 3. If I plug a 3 in, I get 3 minus 1 times 3 minus 1, which is 2 times 2, which is 4, which is positive. And that means this entire interval is positive. And then I'm going to check 0, because I love to check 0. It's so easy. When I plug 0 in, 0 minus 2 times 0 minus 2 is a negative times a negative, which makes a positive. So this entire thing is positive, which means the answer is, again, either all real numbers or no solution. So since we need the entire thing to be greater than 0, it is. Every single one of these points is going to be greater than 0. Now, graphically for these two, how could you have done these graphically? If this is a parabola with no real zeros, but has a y-intercept of 5, then it looks like that, which is never less than 0. You can get that answer pretty fast. This one is an upward parabola crossing at 4. Where is it going to be if it has, it did have a 0. And it bounced at 2. Remember, if the 2 zeros are the same, then it's a bounce. So this one goes like this. So where is it greater than 0? Ooh, not all real numbers. Because it's not actually greater than 0 right at 2. Right at 2, it's equal to 0. So it's only greater than 0 up to 2 and then after 2. So how can you write that interval? Negative infinity to 2, not including 2, and then from 2 to infinity, which is a little bit cumbersome. That is probably, I think, how your book expresses the answer. But you're welcome to write all reals, x is not equal to 2. So it's possible that, right, both good. It's possible you're going to get a homework problem and you're going to think it's all reals. You're going to look in the back and be like, not equal to 2. This is why that could happen. Honors definitely look forward to giving you something this tricky and seeing if you can get that exactly right. CP, I'm not out to trick you. I just really want you to be able to do this basic concept of factoring, making your test interval, and writing your answer in interval notation. All right, last one. So I'm doing another one of these because I do think that they're the trickiest. So I'm going to give them a common denominator, although right away, x is equal to -2 is going to be one of my critical points. You always have to look at the denominator. I chose another one where it's negative because a big mistake is forgetting to distribute that negative. It's x plus 12 minus 3x minus 6. So watch out for that distributing of that negative. Over x plus 2. I'm just going to change it to equals to 0. I clear my fraction. And I also simplify. So I get 4x plus 6 is equal to 0. Oops, sorry, not 4x. That was a negative 3x. Negative 2x plus 6 is equal to 0, which is 6 is equal to 2x. So x is equal to 3. So here's my 3. Again, notice that these number lines are nothing fancy. So I'm going to test in negative 2x plus 6, which is what this simplified to. But you do have to leave the denominator. Leave the denominator for the test because you have to test it at this stage because the x minus 2 is going to change things. So let's pick 4, which is right there. 4 is going to give me negative 8 plus 6 over 4 plus 2, which is a positive and a negative. I do love just doing positive and negative. It's much easier than getting the actual number. I'm going to check 0 in this section. So 0 plus 6 over 0 plus 2 is a positive over a positive. And in the last section, I'll check negative 5, just to show you don't always have to check negative 3. Negative 5 times negative 2 is 10 plus 6, which is positive, over negative 5 plus 2, which is negative. So it does come out to be a negative number. So now we can identify our intervals. We're looking for where this is greater than 0, which is right there. Unfortunately, this is another one where it's not equal to 0. So it is going to look like an ordered pair. But that is my final answer. It's the interval from -2 to 3. One last time for my graphing people. How could you have done this? Well, this has an asymptote at -2. It has a horizontal asymptote at -2 also. The y-intercept when x is 0 is 3, which is 1 point in there. And my x-intercept is where the numerator is equal to 0, which would be 3. So it comes down, it goes like that. Oops, missed it. Comes down, goes like that. I could test a point, but it looks like that, which means it is negative for sure everywhere before 2, and then it's positive, 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 but once it gets to 3, then it's negative again. So this is the only section where it's positive. Everything else is below the x-axis. So another great way to do it. Great, we did it. We got to the end of chapter 2. There is a review packet that you can work on that is extremely similar to the test. And you should make a chapter outline, chapter appendix for CP to make sure that you have everything you need to get a great grade on this test. Have a great day.